Hi, everybody, and thanks for attending today's webinar called Do Design Quality and Code Quality Matter in M&A Tech Due Diligence? My name is Kevin Collins with Synopsys, and I'm here with Dan Sturdivant, CEO and co-founder of SilverThread, as well as Niles Madison, Senior Manager, Black Duck Audit Group. These guys will be taking us through the presentation today. Welcome, guys, and thanks for joining. Before we begin, I'd like to go over a few of our housekeeping items. If you have any questions during the webinar, feel free to submit them in the Ask a Question section. We'll get to those at the end of the presentation. If you have any audio issues, please click on the Ask a Question button in Not Hearing Audio section for support. If you can't resolve your audio issues via support, it's easiest just to exit the webinar and enter back in. That typically resolves any audio issues you may have. If you have trouble reading the webinar slides, feel free to expand your window to full screen. I'll also be sending a follow-up email with the webinar slides as well as the recording. Finally, there are quite a few attachments to this webinar. Please be sure to check them out at any time on the Attachments tab. Thanks, everybody, and I'll pass it over for Niles to get us started.
Hi, everybody. During today's webinar, we'll be going over a few things here around code quality and design quality are going to be the main functions of this. So today's agenda, we'll be covering, in general, considerations during a technical due diligence and the risks involved, understanding what code quality is, understanding what design quality is. Then we'll be going over a little bit about how we go about assessing each, and then we'll follow up with some questions and answers for you later on. All right, so M&A due diligence and quality risks. So in general terms, we speak about due diligence during M&A transactions, that there's a few things you need to cover. There's one, you need to confirm. So you need to confirm what the buyer has already concluded about the organization. So this could be things, what does the company do? Who are the customers? How good is the product? The company's financials? All sorts of things like that. These are things where you're pretty sure you know what's going on, but you do want to confirm that they are in fact true before you sign on the dotted line. Next is gather. So you need to gather information so that once the deal has been finalized, you can figure out how to integrate people and products into your ecosystem. And then finally is identify. You want to identify any unknown risks that might occur to you, and this is really where our focus will be today, specifically around risks in the code and risks in the architecture. And really, we've broken down technical due diligence into 5 areas of concern, with the more high-level items at the top and the low-level at the bottom. So your high-level items are going to be much more subjective and involve a lot of interaction with people, versus the low-level ones are going to be far more objective and rely on tools and give out kind of hard numbers and facts. So for each of these product and strategy, so during an M&A, you're really looking to see, an acquirer is looking to see, is this a good fit in terms of for the product and strategy in terms of quality and fit? Is it going to match what your corporate strategy is, and does the product live in a similar tech stack that can make it easy to implement? For people, most acquisitions will involve taking on people. There will be some acquisitions that are straight software assets, but the reality is typically, even if that's the case, 1 or 2 people at least are going to need to be brought along for a year, maybe 2 years, to help get things integrated into the system. With that, there's also, if you're bringing in an organization with and taking the team on, are there going to be redundancies? If so, how are you picking and choosing who stays and goes? Next is process and tools. These are really the process and tools that are used to create the software assets themselves. This is most important if you're going to take an existing dev team and infrastructure and port it over and maintain it. Maybe less important if you're planning on getting rid of the full team and want to replace it with your own staff and processes. But it is something to consider with that. And for the last two items, the architecture and code, this is really the focus of today's talk, and these are the low-level things and that can spit out more quantitative numbers and more factual information versus opinion-based items and making judgment calls on things. But these are really looking at how the code is all put together. So the code itself is kind of the building blocks of an application, and then the architecture is really looking at, how is it all kind of tossed together. And when we speak about the dimensions of software risk, Black Duck Audits views these things in three specific areas. Legal, so what are the third-party components in the code base and their associated licenses? Will you get sued for releasing code against the definition of the licenses? There's security risk, in what ways is the application vulnerable to outside attacks? And then quality risk, which again is the focus of today, where we're really answering two questions. One, is the code well written? And two, is the architecture healthy? So in general, what those will end up telling you is, what is most of your money going to be spent on? Is it going to be non-value add activities, if you want to think, fixing bugs, maintenance, refactoring, or can those resources be put towards new features and capabilities going forward? So poor quality can really slow down development release schedules and decrease functionality. So during our assessments, both of the figures you see here are based off of actual research. So we found that over several years in all code bases, we're seeing over 60% of code bases are in fact released with blocker issues. So these are organizations that have been looked at by, we're looking at them in terms of an M&A, and we're finding that over 60% of them are coming out with blocker issues living in the code. So we're seeing this a lot across the board, and that's per engagement. That's not just within any one code base. And on the right, this is looking at, which we'll get into more, it's looking at the architecture, and when a code base is well structured and has a clear hierarchy and flow of data, it's much more easy for developers to work within it. Therefore, they're much more functional and able to do more quality development throughout the year. So next, we're going to help you understand what code quality really is. So code quality, it's not as clear-cut as security and licensing risk, where a lot of people can put a finger on, security, can I be hacked, and licensing, can somebody sue me for this? And there's that clear actions in the market that can be taken against somebody for this. But code quality can sneak up on you, and it lives forever. If you have poorly written code, you're more prone to bugs, or by definition, there's bugs. It won't scale as well. It's harder for developers to be integrated onto it. And thus, it kind of drags out the time to develop new features. And it's going to result in you needing to refactor and redesign things, or ultimately end up having to hire much more senior developers rather than being able to put on junior developers within there. So we're really looking at the effort it takes to kind of maintain these code bases based off of what's been written. Is it code clearly written? Is it not? Is it well commented? That's what we're really speaking about when we speak about code quality. And some metrics you can think of for this is file issues versus complexity. In the graph on this chart, this is again based off of actual data over the years, and we found that as the complexity of a file increases to this 300 to 400 level, the number of bugs per file goes up exponentially. So these are observations that we may have concluded before, but we didn't have clear facts, and over the years we've been able to find, hey, we actually have proof that with complexity comes a rise in file issues. We're also looking at the average number of high complexity in terms of file and methods. So which files are going to be more prone to having these issues? Large packages, if the code base isn't well designed with clear folders, articulating which that there's third-party components in one folder, there's your reporting module, there's your administrative module. This is stuff we're looking at to see, does it in fact make sense from an outsider's point of view coming in and looking at the code base. And then finally, duplicated code. This is stuff the metrics we see a lot can be a little alarming. There's a lot of duplicate code out there, and it's more troubling when you find multiple multiple instances of the same file, and there's a bug that was fixed in one, but not the others. This is the kind of stuff that we're looking at in terms of code quality and trying to pull out. So it's really at the, you can think of it as a single line of code or methods. So it's much more micro than sort of the architecture point of view that we'll be speaking of next. And as from here, Dan, if you want to take it over to speak a bit about the design quality and what we could do there.
Great. So thank you. Now it's just talking about code quality, and code quality is very important when you're trying to understand the health of the code base. If you have a lot of complexity inside individual files in your system, then that makes it hard for developers to understand what's going on and make changes confidently, knowing that they're not going to be introducing or exposing bugs in the system. Now, code quality measures traditionally look at individual lines of code, individual functions or methods or classes or files, and it's kind of like thinking about the quality of individual bricks in a house, right? So it obviously matters. You care about the strength and the geometry and the color of the bricks that you have in your house, and that's a bottom-up approach to looking at the overall quality of a system. The idea is that you would measure the quality of these individual parts and add that up and consider it all, and then think about that as the quality of your house. But there's another view that you can take, because if you only do that, you're ignoring all the information about the mortar in your house. You're ignoring information about the holistic properties of the house and how walls are formed and how they come together. So design quality is more of a top-down approach to thinking about the quality of your house. You're thinking about the relationship between the parts, and do they form nice modular structures with good clean APIs, reuse, and other things. And so we care about both code quality and design quality when we're thinking about the health of a system from a maintainability standpoint, from a defect standpoint, and also from an economic and a developer productivity standpoint. I'm going to go on to the next slide. These are studies that we've done looking at both code quality and design quality within large software systems, a variety of them over a long period of time. We've done research out of MIT and Harvard Business School, working with several different companies, large and small, to connect quality issues that we can gather using an automated scanning technique in a code base and the economic or business performance KPIs that result from that. It turns out that when developers are working in unhealthy parts of a code base, we found that they can only produce 8 features in a year. And those same developers were spending 69% of their time fixing bugs. Whereas if you look at those same developers when they're working in healthy code bases or healthy parts of a code base, those same developers are producing 20 features a year and only spending 20% of their time or 1 day a week fixing bugs. So very clear economic differences and business performance differences that are caused by the quality of the system they're working on. So if you are acquiring a company or taking responsibility for a code base that you're going to be developing moving forward and maybe want to scale and put in new places, you should be very interested in the quality of the system from both of these perspectives, both a code quality and a design quality perspective, because that will ultimately have a very strong impact on the experience that you have as you move forward with that asset. If you're trying to improve it, enhance it, have a new development team work inside it, get up to speed inside it. We've done a variety of studies statistically linking these code and design quality measures to things like revenue generation potential inside the system, cost reduction, optionality. Can you take a code base and modify it for some future purpose based on future business demands? We can help people understand, will people be more agile? Will you have better predictability around your schedules? And these techniques can also be used to help people understand the safety of a system. If it's a safety critical system, whether it's a medical device or a automotive or aerospace system, or maybe a financial system that if it goes fails in some way, you're gonna suffer a lot of consequences that you don't like. You want to know that kind of thing. This is also predictive of how easy it's going to be to take a system to a cloud is, and also how cyber secure a system might be. Now, let's describe what we mean by design quality. Imagine that you've got a code base that is so complicated that in order for a developer to work inside it, they need to have an IQ of 400. Well, the reality is no one has an IQ of 400, so if a developer is expected to do that, they're going to fail in a lot of ways. They're going to be unproductive, and they're going to be constantly introducing or exposing bugs in that system. So what developers do, or what system architects do when they're creating these software code bases, is they make them modular. They will cut that 400 IQ code base into 4 different parts, with 4 different subsystems managed by 4 different individuals or teams, each of which can focus on a subset of that system, therefore only requiring them to have an IQ of 100 while confidently making changes within their parts. Within that module, you have a fair amount of complexity, but you'll wrap APIs around each individual module. So one team has a simplified understanding of the code developed by other teams within their organization. Other things that we care about when we're thinking about the quality of a code base from an architecture perspective is layering, right? The concept that there's a top and a middle and a bottom. Maybe at the top you have a GUI. Maybe in the middle there's business logic or middleware. Maybe at the bottom there are utilities like operating systems or device drivers. But having a clearly defined layout allows the developers in an organization to function better and to evolve the code base in a healthy way. It's good to have clearly defined dependency structures and also to have reuse so that at the bottom of the system you have one thing that you're using because it's been built once and it's been built well. Now, unfortunately, in our experience over 15 years of research and development out of MIT and Harvard, the picture on the right here is the picture that engineers tend to draw. This is if they go to the whiteboard, they're going to draw their system in this way when they're creating a block diagram. This is generally what you see in the documentation that you might examine when you're contemplating an acquisition. Unfortunately, 80% of the time, the system that we scan actually looks more like the system on the left in one way or another in some significant ways. And it's important to understand the difference between what developers think they have versus what they actually have, because these red linkages that couple the system together in different unexpected ways are the places where bugs happen, and it's where developers are pulling threads, one thread after another as they're trying to make changes. These are the things that make it very hard to maintain a code base. Now, the development of the code bases evolved to be unhealthy as part of a natural process. It's sort of an entropy process in a system. It's not necessarily anyone's fault. If you don't have controls in place to prevent an healthy architecture from becoming unhealthy, it's just a natural process that unfolds. So it's important as you're moving forward to put controls in place to prevent that kind of degradation from happening. But if you're acquiring a company, you want to get an understanding of how healthy is it now, and also how hard would it be to remediate if you wanted to clean up some of the spots within a system as you're moving forward. Let me provide a concrete example as to why that matters. The last slide was fairly theoretical. This is an example of a video game company that we've worked with to help people understand their architecture. Now, if you're a video game company, you have a video game engine or platform that you develop that might have subsystems like physics and a rendering subsystem, Xbox drivers, PlayStation drivers. This is code that is reused across a product line in a product platform. Now, this organization also had several games that they were developing for the Xbox and the PlayStation. The first one that we have in this picture has a bad guy subsystem, a vehicle subsystem, a weapon subsystem. This happened to be a violent game. It's a first-person shooter. But they're developing several games on top of this platform, including what's pictured here as Game 2. And I'm going to tell the story of why this organization almost missed their Christmas releases for their video games. And I hope you can appreciate that as a video game company, if you ship all of your video games in January, that's an existential problem for you. So you, as your acquiring companies, you want to know if these kinds of problems exist inside the code bases that you're looking at. So here's the story. We did a scan of this code base using the automated tooling to do design quality analysis, and immediately found that there were some linkages where the game code, the engine code, was depending on code implemented inside individual games. This was a clear violation of the architectural intent. You would expect in this organization to have dependencies from the individual game subsystems down into the engine, but not from the engine to the games. We were able to find hundreds of these linkages and pinpoint specific files and specific lines of codes where they were occurring. Now, when we called the architect and spoke with them about why this was happening in this system, they told us that it had saved them a month of time during development. They recognized within the engine team that Game 1 organization had developed some useful algorithms and functionality that they wanted to make generic and share with the rest of the organization. What they should have done is they should have taken that functionality out of the Game 1 code base, pulled it down into the video game engine. They should have hardened it, made it generic, documented it, and broadcast to the rest of the organization that that functionality was now available to everyone. They chose not to do that, however, because doing that would have cost them an extra month worth of time, and it would have required them to change the ownership of that code from one organization to another within their company. It turned out they decided it was going to be too hard to do, so instead they just made calls from the engine to the game code directly. Now, it seemed like it saved them a month of time, but that created a lot of technical debt in the system that had enormous economic consequences down the road. And here's why. Years later, around the May timeframe, Game 1 organization made some changes to that functionality that actually were a local improvement to that game. It improved some behavior or some performance of that system. Now that patch, along with hundreds of other patches, got merged into their CI/CD pipeline and also merged with hundreds of other patches developed by the engine team. And then all of those changes landed on the doorstep of Game Team 2. Now, around the June timeframe, that all happened, and Game 2, their organization started experiencing a critical defect that they couldn't diagnose. So they spun up a team to try to figure out what was going on, and they spent a month trying to figure it out until they finally decided that it wasn't the fault of their organization. It seemed like it was an integration issue. So then they spent several months trying to diagnose it with a team, a UK-based team and a New York-based team across this organizational boundary, trying to figure out what was going on. And there was ultimately a fair amount of finger pointing going on until they finally realized that it was caused by this change in Game 1 that was impacting all of them. Now, the problem was that it took so long to diagnose and debug that now they were racing against their Christmas release to try to get this fixed. It's already October, November, and they've got to get this game released for Christmas. And so for the purposes of Game 2, now what this organization had to do was they had to roll back to an older version of Game 1's code, an older version of the engine, so that they could release this. And I'll pray on Christmas morning that it wouldn't all collapse out from under them. So, Niles, I'll kick it back to you if I want to talk about assessing code quality and design quality as part of the audit.
Yeah, thanks. So for the next bit, we'll be kind of talking more about how we go about doing each of these assessments. So code quality, again, we're really looking at, as I mentioned before, is the code well written? And for this, we use static analysis tools. We use both some internal to Synopsys. We use some third-party as well as some kind of homegrown tools to really get all these metrics that we want to uncover. And then from there we use expert human review. So we're going through and looking at specific areas of the code base maybe that have high complexity and using the where there's smoke, there's fire methodology to kind of really see what's going on within these code bases. To do so, this does require access to the source code and the library. So this is something that during an acquisition, the acquirer might not get access to, but as a trusted third party, we do get our hands on the code pretty much every time and have the ability to do so. Our focus here is really looking at the quality of each file and method, and then relate that back to the industry standards and compare it also against well-known open source components, just to give context to these metrics versus leaving you out there wondering what each of these measurements actually means. And ultimately, the code is evaluating code practices, your complexity, are people documenting the code well, low levels of duplication. Again, really focusing on the what level person do I need to put onto these code bases if I am going to hire new developers. The easiest one to say is senior developers versus junior developers. Which one do I have to hire? Do I have to hire principal developers? And now my costs are going up even more. And really the sample metrics are file issues versus complexity, how many large modules do I have in my code base or packages, is everything in one single file, or is it broken up nicely so that I can have multiple people working within multiple parts of the code base and not worry about them running into each other. Yeah, so it's really looking at the quality of what people are doing on a day-to-day basis. And then a design quality audit is somewhat similar. We are looking at things at a code level. So again, we do require access to the code and libraries, which we already have as part of the code quality audit. And then it's, again, tool-driven with expert human review to figure out what's going on, where, and potentially why. And really the focus is really looking at the architecture from a different point of view. So whereas most architecture assessments take a qualitative approach and more high level, this is what's actually going on in the code base rather than what should be going on in the code base. And it's, again, looking at the architecture, modularity, layering, APIs. So is it monolithic? Is it microservices? Things like that are which we're really looking at. Dan, did you have any things you wanted to add to the design quality piece?
Yeah, no, I think it's just it's good to look at both because both obviously have an economic impact on the future maintainability of these systems. So and the other thing is that it's important to do it in a quantitative way as well as the qualitative way that's traditionally done, because generally, organizations and people inside these code bases, they don't often know what the structure of a code base is, and so it's important to check the structure of the code base against what people believe it should be.
Yep, perfect. So conclusions. Again, it's just important to know what's going on before an acquisition. So similar to getting a house inspected before you make that large purchase, same thing should be done during the time of an acquisition of a software asset or company. You want to look under the hood before you buy. Same thing applies here. Oftentimes people look at for an acquisition, we're looking at the finances of an organization, but not the actual building blocks and architecture of these products that they're really investing all this money in. So you do want to do that. And poor code quality and design quality can seriously slow down integration. So if we can find out that there's more bugs being introduced than you were expecting, you're going to have to spend more time fixing those bugs. And it's important to assess all aspects of quality. Just because it has good code quality does not mean that design quality is going to be equally good, and vice versa. We've seen both. We've seen great architecture, horrible code quality. We've seen horrible code quality with great architecture, and we've seen them both appear and at the same time, and both been lacking. So it is important to kind of look at things along all dimensions of quality.
All right, so that wraps up the presentation portion of the webinar, so we can open it up for questions. It's not too late to ask a question. If you want to do so, you can just type your question into the Ask a Question spot in the session. All right, so let's get started here. The first question that came in, how do you consider test code and test coverage in your assessment?
Yeah, so for the code quality audit, what we're really looking at is, and I guess to give some context, the code quality audits were born out of the fact that we were already getting code for these open source assessments, and we thought, what else can we provide? What value can we provide now that we have the code? So the code quality audit is looking at the proprietary code that's been written. So we do separate out the third party, and that includes open source and commercial components. So we do take that out. We take out generated code, and we also remove the test code as well, it's more of an insight into these developers that I'm about to make a significant investment in. What's the quality of the code that they're actually writing on a day-to-day basis? Not to say that test code and test coverage aren't important, but we're really looking at the day-to-day writing of code. For test coverage, we treat that more as a qualitative portion where we ask for test coverage results and things like that. But we do remove it from the standard assessment.
Okay. Next question is, what is the risk if we did not do a software quality audit before an acquisition?
Yeah, so there's two sides for this one. There's the code quality audit and design quality audit. So I will speak to the code quality and then let Dan take the design quality. So for the code quality, the risk is that you might then take on code that is full of bugs, overly complex, and a lot of duplication. It may not even be readable from an outsider. A code base that's been developed by four guys working in one room for the past 10 years, they may not have documented a lot of things because they can just turn to their peer next to them and ask questions about what's going on. Versus if you want to double the team size, is that actually a practical thing that you can do, or is it going to take away all of the time of those 4 developers to get somebody else on board? So it's really letting you know how easy is it for others to join in on this code base and maintain that code base, or is it you need to put some golden handcuffs on existing developers to help them get the code base to a point where it can be easily worked on. And we've also had customers that have spent as much, this is from their mouth, spent as much money fixing issues in the code base than they did on the actual acquisition. So it's really just letting you know what you've got, what you're getting your hands into before you purchase.
Yeah, and let me sort of tell a story here. We've of maybe the most costly acquisition that we've seen that was someone buying a lemon. We worked with an organization that a government organization that wasted $850 million on a project that was doomed to failure. We actually came in and did a post-mortem after the fact. Unfortunately, the government had allocated $350 million to a project that was supposed to integrate 43 separate systems into a system of systems. But once they were $850 million in, Congress pulled the plug and said, okay, we're going to do something else now. Afterwards, we went in and we assessed the one of the 43 code bases that was chosen to be the platform upon which everything else was built. It was a legacy system that they decided to go with. And when we did the design quality assessment, realized that it was the most challenged Java system that we had ever seen in 15 years. If they had known that going into that decision, they never would have chosen that as the platform to build on top of, and therefore never would have wasted close to $1 billion. A simple assessment can help people avoid a lot of downstream pain in an automated and simple way.
Thanks, Dan. And actually, here a follow-up question to this came in that probably makes sense right now is, are there any financial numbers an M&A organization can use if they find poor quality, and how do we assess the impact of the technical debt?
Sure. Miles, do you want to answer that one first, and then I go, or how do you want to do it?
You can go. You're on a roll.
Okay, cool. So Silverthread, obviously partnering with Synopsys on this effort, we've done a lot of statistical work connecting code quality and design quality attributes of a code base to financial impact from a productivity standpoint and from a defect standpoint. Therefore, we can do predictive models. Take a code base, capture design and code quality metrics, and then say things like, in this code base, if all of the patterns that we've seen previously hold, we would expect that $500,000 out of every future million spent on its development and maintenance will be wasted. And we can say that because we would predict impaired productivity or excessive defects that have to be fixed. So we're using predictive analytics to make statements about the future maintainability and risk associated with development in that code base that you were acquiring. Now, predictive models aren't perfect. It's not calibrated for that specific organization. Down the road, if someone's interested, we can calibrate those models by tying into their management systems. But in a very rapid, automated way, we can do those predictive analytics so that you can understand how systems are benchmarked against each other and what kind of waste and cost might occur if you are taking on responsibility for some software asset.
Great. And yeah, from a code quality point of view, we don't report back any fiscal numbers. We don't have the predictive analytics that Silverthread can provide. But we do provide a list back of, when we do these code quality audits, a list of the known issues and expected technical debt. So it does come out in a spreadsheet, and it can be viewed, and it's not meant to be taken as exact numbers, but it does give some sort of overview of expected tech debt that you're going to take on by this acquisition. We do put that into context as well, saying, here's what the average code base has in terms of blocker issues, critical issues, major issues, but we don't have the fiscal numbers of the implications that we'll have on a code base.
All right. So the next question that came in is, typically, who should be involved in the software quality due diligence process?
So that, I think, really depends on the organization that you're dealing with. From the target side, it's going to be somebody who does have working knowledge of the architecture, so they know which parts of the code base should be assessed, which pieces belong to which application, so we can accurately report back on the findings. And then in terms of digesting the reports, you're going to want to have somebody who will play a key role in helping to integrate and set a remediation plan and integration plan for the organization. But yes, you're going to need somebody technical on each side to kind of get the ball rolling, as well as digest and help plan according to the results.
And I'd say, what's interesting here is that, traditionally people, think, okay, we're gonna do a quality check on the code, and that's purely, something that the technical people might worry about in depth. But because we're connecting this to economic numbers around the maintainability of the code base moving forward from a financial standpoint, that should be of interest to the people who are concerned about financial projections moving forward if this asset is really going to be driving, the development of this asset is really going to be driving whether an acquisition is successful. So I think there's a case to be made that other people, non-technical people, more people interested in finance and risk, should be interested in some of these results as well.
Okay. And Dan, I think this next question is for you. You touched on it a little bit in your presentation, but what's the difference between quantitative and a qualitative approach to design quality?
Okay. Well, maybe Naz, do you want to talk about the qualitative work that's done, and then I can speak about quantitative?
Yeah. So I'd say when it comes to architecture, your historical approach to that would be a qualitative approach where you're sitting down with an architect, asking what the intended design is going to be. We're talking to folks. We're kind of giving a look at code structure at the code level, but it's not really knowing which files are calling which other files. So it's really more conceptual and theoretical. Versus, I think what Silverthread does is far more accurate in terms of what's actually happening. But I can let you talk about the actual.
Sure. Yeah. So if you get the senior architects in an organization and you sit them down and you have a detailed conversation about the structure of the system and how they've built it over time, that can give you good insight into the maturity of the organization and how well you think they might be doing. But often in systems, especially systems of any size, ultimately there's no way that one human being can really understand all of what's going on in that code base, which is why we often find differences, and sometimes significant differences, between what people tell us versus what's actually there. And that's the reason that it's important to do the quantitative assessment as well, to sort of assist in those conversations and help people see, what truly is in the system, and have a real accurate understanding of how that is having an economic or a risk-related impact that people, might just not even be appreciating when they're looking at it. But if you want a real comprehensive look at the risk that you're taking on, I'd say that you also really should be interested in doing an automated quantitative analysis in addition to any qualitative work that's done.
Okay. The next question is, do you support us installing the product on-prem with no access to the internet?
So yeah, I think that Dan, I'll defer to you, as I believe that should be a CodeMRI question.
The answer is yes. From the perspective of the CodeMRI tool, we can support all sorts of different ways of working together. Some people ship us their code, and all the way to other people are using our system inside highly classified environments where we'll never see the results and nothing is connected to the internet. So we can support all of those different kinds of use cases.
Okay. The next question, can the tools be automatically executed as part of a CI/CD pipeline?
Yes. With CodeMRI, we have many experiences with people, with us setting that up, as well as our customers setting that up. Everything can be run from command line interfaces, and from there you can integrate it into a variety of tools.
Okay. One more question and then we'll wrap it up for today. The last question is it too late to do an audit after the transaction?
Yeah, I'll take this. It's never too late to have someone come in and a fresh set of eyes on things, and we give an objective assessment versus if it's the target, if somebody on the target team might kind of lean more favorable towards themselves versus another party on the acquiring team might be a little harder. We come in and just give things more factual, and it's always good to know what's going on and where, so that you can, again, come up with a remediation schedule that works for you, prioritize things, set up a roadmap. So it's not too late, and we have people we've got customers that frequently come in for internal assessments just to get a good idea of what's going on behind the scenes. Because if you're at the C level, you don't really know what's going on in the day-to-day. You know the gist of what's happening, but you don't really have that detailed report or insight into the code base itself.
Yeah, and I'd say once you are responsible for a system or several ongoing development projects inside your organization, it's good to understand the economics of what you're dealing with, the risk of what you're dealing with, and frankly to have tooling that can generate plans for how to improve the technical health of your system and subsequent, as a result, improve your business performance. So that's something I would certainly encourage doing internally, as well as when you're evaluating third parties to either be acquired or who are delivering software to you.
Excellent. Well, thanks, guys. I want to thank both Niles and Dan for the presentation today, as well as everybody that joined us live. As a reminder, this webinar was recorded, and we'll send out a link in an email to the recorded version, and you'll also have access to all of the resources on the attachments tab. Thanks again for joining, and we look forward to seeing you on future webinars. Take care, everybody.